All right, extra problem number 10 from the fall ACP review. It says that the domain of f of x equals 2x squared minus 1 is restricted to this. Which graph represents f negative 1, which means the inverse? Which one represents the inverse? So the calculator can actually tell us this as long as we know how to restrict the domain and how to find the inverse. Here's what we do using this technique of using the calculator. What you do is to restrict the domain, you've got to use piecewise. So I'm going to go over to graph, and when I type in the equation, 2x squared minus 1, instead of typing it in right here, what would happen if I did, is I'll just show you real quick, it'll give you this whole graph, but it says it needs to restrict the domain. Now domain means x values, and it wanted to restrict it to the values 0 to infinity, which means this part of the graph would be cut out. Now the only way I know how to do that is use piecewise. So I'm going to come back up here and change my equation. So again, that part of the graph should be cut out. And instead of typing in like this, I'm going to go to piecewise, which is next to 9 right here. If you choose that 3 by 2 box, you tell it how many equations. Well, there's only one equation with its domain. So the equation was 2x squared minus 1. The domain was, remember how we can't use this one, this type of format, you see, because it automatically puts that bracket, so we have to change it. So the way you would change it, if it was restricted to 0 to infinity, since it's domain, this represents an x, so x is in the place of comma, and you're going to have these two symbols, and you always have these inequalities pointing this way. The bracket means you can be equal to. So you're working with this. But when this is called set builder. When you use set builder, you do not include the infinity. So that's what we're going to type in right there. So 0, control equals is where you get these inequalities, is less than or equal to x. Now when I press enter, you'll see this part of the graph will disappear. This part will stay. There it is. So that's the function with its restricted domain. To find the inverse, what you can always do is press menu, actions, text. And you're going to type in x equals f1 of y. X equals f1 of y. Now as soon as I hit enter, nothing will happen. But this is how you find the inverse. What you have to do is you have to drag it either to the y-axis, as you can see the graph comes up, or the x. Either way, once it hits an axis, it'll graph it. That's what the inverse is going to look like. Which for us, we can see the answer could be h, it could be f, G and J are out because they're not even close. This one was shifted. Oh, wait, never mind. I'm sorry. It shifted left one. So those two are out. And it's going to be either this one or that one. So what's the difference in these two? Well, I can see this one approaches the point, looks like 4, 1. This one hits 1, 1. I go to my graph, and this looks like it'll hit 1, 1 right there. So I'm going to say the answer is G. Now, some of you might be going, man, that's too close to tell. I don't want to use that method. Well, if you can graph this using piecewise, the second way, instead of doing this x equals f1 of y, you can press Control T. And for an inverse, you just switch x's and y's. So this is 1, 1. It's going to be the same thing as 1, 1 when you switch it. So the graph should hit 1, 1. Oh, I'm sorry, I circled the wrong one. J is the correct answer. G's out. Because it hits 1, 1 there. All these other graphs do not hit that point 1, 1. So I'll just do a little x and y table here. We know we should have 1, 1. This one does hit it. This one doesn't. Okay, and then we can go back over here. And another point would be 2, 7. And so when we flip it, it should hit 7, 2. I look at this graph. Here's 7. It does not hit 2. Oh, we already had that one out. Let's try this one. 7, 2. It looks okay so far. This one, does it hit 7, 2? It does. The difference, though, is going to the left. Let's try going backwards a little bit. So I go to my table, and I go up here. Whoop. I have 0, negative 1. The other point would be negative 1 and 0 when you flip it. It should hit negative 1, 0, which this one does not. And so it's out. This one does, and that's why it's good. So that's the second technique. Finally, the third technique is doing good old-fashioned algebra. You switch your x and y, and you solve. So we would have x equals 2y squared minus 1, and the domain's restricted, which means later we'll have to change it for the range. To solve this, we need to add 1 to both sides. So when I add 1, I get x plus 1 equals 2y squared. I then would divide by 2, which gets rid of that. And now I'm left with x plus 1 over 2 equals y squared. Finally, the way to get rid of a square is you take a square root. But anytime you add a root that's not originally there, an even root, you have to do a plus or minus. So we would have y equals plus or minus square root of x plus 1 over 2. Now here's where this gets tricky, is you'd have to come in with the domain restrictions. The original was, let me graph this real quick. The domain was restricted, so this one we would restrict the range. Let's check out here. We have x plus 1 over 2, and we do it as the positive, and then I'm going to graph it again as the negative. So I would have, what did I do there? I'm sorry, messing everything up. I have x plus 1. Where's my x? X plus 1 over 2. And then I would graph again and have negative of the same square root, x plus 1 over 2. So when you look at this, here are the two graphs, we had the plus or minus. But if the original domain was restricted to that, that means the inverse's range has to equal this because you switch x and y's. So the range, we would not include anything down here. And so you would only include the positive part of the answer. So you would actually write that the inverse, once restricted, is simply the positive x plus 1 over 2 square root. That would be your answer here.